Fuel economy of vehicles. Here we'll discuss about the fuel economy of the hybrid electric vehicles. The fuel economy of conventional vehicles is calculated as the fuel consumption per 100 kilometer or miles per gallon, that is MPG. So generally, it's considered as how many liters per 100 kilometer is the consumption. There are usually two figures, one for city driving and one for the highway driving. Also, there is an additional fuel economy figure that evaluates the combined fuel economy by combining the 55% city and 45% highway miles per gallon figures. So, for example, this can be calculated fuel economy miles per gallon combined by taking the economy for city and economy for highway and dividing it by the percentage of the city and percentage of the highway. That is 0.55 and 0.45. The above fuel efficiencies are also called as the tank to fuel efficiency. This does not reflect the losses during the refining and distribution. It is sometimes easier to compare the overall efficiencies of the conventional vehicles and electrical vehicles. The plug-in hybrid electric vehicle economy is generally a confusing term, such as which figure should be used. It has two different scenarios: all electric capable plug-in hybrid electric vehicle and blended PHEV plug-in electrical vehicles. The all-electric capable plug-in hybrid electric vehicle, it is useful to indicate the electric range in miles or kilometers and associated energy consumption during the particular range in kilowatt hour per mile and potentially gas equivalent, that is MPG, miles per gallon. Another set of figure is required to show the miles per gallon during CS mode, that is the charge sustaining mode driving. So here we can see these two figures. We can calculate in the first all electric range, suppose it is 40 miles to 40 watt hour per mile and 140 miles per gallon, that is the gas equivalent. Another is the fuel economy in CS mode, that is the charge sustaining mode. It is 30 miles per gallon city mode, for example, then 33 miles per gallon highway and 32 miles per gallon combined. In this way, the fuel economy can be also indicated. For blended plug-in hybrid electric vehicles, since there is no pure electric driving range, it is a blended, so IC engine is also combined. It is useful to label the fuel economy in CD and CS mode separately. The mode should be considered, that is the charge depletion mode and charge sustaining mode. It will be preferred to include the electric energy consumption during the CD mode also. So considering the above facts, these fuel economies are indicated in the following figures. So say fuel economy AD mode, 80 miles per gallon city, 75 miles per gallon highway, plus electric energy consumption 120 watt hour per mile, and CD mode range, charge depleting mode range is 60 miles. In the second, it is shown the CS mode, that is fuel economy in charge sustaining mode. It can be indicated 30 miles per gallon for city, that is in CS mode, 33 miles per gallon in highway, 32 miles per gallon combined, and charge sustaining mode range is indicated 360 miles. Another is the utility factor approach to fuel economy clarification is to use the utility factor. So earlier was the based on the fuel economy and it was based on the fuel consumption per 100 kilometers or per miles per gallon. Now here it is a utility factor approach. The utility factor is defined as the ratio of the CD range, that is the charge depleting range of plug-in hybrid electric vehicle to the total distance driven in daily commuting or daily run by all the propulsion, all the population. For example, a CD range of 20 miles will result in a utility factor of 40%. Using the utility factor, the combined fuel economy can be expressed as fuel economy is equal to 1 upon utility factor divided by fuel efficiency in the CD mode plus 1 minus utility factor divided by fuel efficiency, fuel economy in the sustaining mode, that is a CS. So we can calculate the utility factor up. We can use the utility factor and calculate the economy. Here the graph shows the utility factor versus the all electric range. So the variation is shown in the figure. Power management of plug-in hybrid electric vehicles. The goal of power management is to minimize the fuel consumption for a given drive scenario. So the vehicle should use the minimum fuel, and that is a function of the power management. The plug-in hybrid electric vehicle involves the operating conditions of both CD mode, that is charge depleting mode, and charge sustaining mode. When the battery is fully charged, vehicle is operated in charge depleting mode, and when battery state of charge reaches a low threshold, it switches to CS mode. In charge depleting mode, the vehicle maximizes the use of battery energy. In the CS mode, the vehicle will use diesel or petrol to power the vehicle while maintaining the battery SOC at the same level. So the power management will utilize these various modes. During charge depleting mode operation, the vehicle power management is to minimize the total energy consumption by distributing power between the battery and the IC engine for a given driving scenario. Thus, the goal of power management in plug-in hybrid electric vehicle is to minimize the fuel consumption for a given drive scenario. For a blended plug-in hybrid electric vehicle, there is no pure electric range available. It is a combined one with IC engine and electric mode. The goal of power management in blended mode is to minimize the fuel consumption for a given drive cycle and a given total available battery energy. And this is related to the characteristics of the power sources. So power management is basically decided by the characteristics of the power sources. If the drive distance is longer than the electric range, then there are three possible approaches for operating the vehicle. First, operate the vehicle in electric mode until the battery is depleted to a preset threshold, then run in CS mode. So operate in electric mode and then go for the charge sustaining mode, the combined mode. Second, operate the vehicle in blended mode with the engine turning on at power demands and deplete the battery to the present threshold at the end of the total driving cycle. Third mode is operate the vehicle in blended mode with the engine turning on at high power demands but with an optimal battery discharge policy. So the battery will be depleted to the pressured threshold before the end of the total driving cycle. Here we'll see the idealized blended plug-in hybrid electric vehicle model for power management. So as we have seen, there are various approaches for the operation and control and power management. The one that consumes least fuel will be the best choice because the battery exhibit a large power loss at high power output as compared to its normal output power. It may be beneficial to operate the vehicle in blended mode instead of using the high power output of the battery. Thus, the optimization problem can be used or so framed to minimize the fuel consumption and the constraint are subject to the distance and drive cycle. The total vehicle power requested is satisfied by adding the engine output and motor output as it is the blended mode. So here we can see into this figure, the fuel is given to the engine. This P engine is the power leveled by the engine. Another PB is the power by the battery and it will be given to the electrical power to the motor and it will provide the mechanical power as the output of the motor. Both P engine and P mechanical, that is PM, will be given to the mechanical coupling and then transmission and then to the vehicle. So P0 is the power given by these two drives. So we can calculate this P output or P0 is nothing but PM, that is the power by the motor plus power by the engine. Also the PB, that is the battery power, will be again the PM mechanical output, that is motor output, and then it will be the losses in the battery and losses into the motor. So this small PB for the battery losses and small PM for the motor losses. So this has to be also considered. Calculate the total power delivered by the battery is nothing but the power converted for the use and what are the losses in the battery and the losses at the motor stage. And considering this, we can calculate the power and power management can be done to minimize the fuel consumption. So overall, you can see the price of battery pack is important in the commercialization of electrical vehicles and plug-in hybrid electric vehicles for a large-scale deployment. The factor that highly impacts the life of battery pack is the charge algorithm or the way they are charged. There are also other factors involved, such as the charging time, that plays the important role in the high attraction of electric vehicles and plug-in hybrid vehicles. So the life of the battery and ultimately the economy of the vehicle will depend on the battery life and the battery algorithm, charging algorithm is the important one, how it charges to increase the life of the battery. It requires multi-level control and power system called battery management system. The more accurate and comprehensive battery management system is the more reliable, safer, and faster charging procedure. Designing a high efficient battery management system requires a very good understanding of the behavior of single cells according to the variations of different parameters and also mutation of these behaviors in a packed state with a large number of cells.